Okay, we're back. So in the last part, I talked about using threads to achieve concurrency in this web crawler example, where we can use a bunch of threads to crawl a bunch of pages. So if I wanted to crawl 100 pages at once, I would start up 100 threads, which is essentially 100 copies of this function running, all adding to this shared queue. Now, the alternative to threads is called async or asynchronous I/O. Now, what asynchronous I/O does is that it will use what's called non-blocking sockets. So this means that as opposed to this example before, where each function call is blocking, which means that the function does not return or finish until the operation is done. So until this connect is done, this execution doesn't go on. Until the send sentence doesn't go on. Until each receive is done, it doesn't go on. So this function might take a few seconds to run if you're on a slow connection, right? It'll go run, wait, run, wait, run, wait, run, wait, and such. So in contrast, what async IO does, or asynchronous IO, is that you start a socket in Python and you call the set blocking method to set it to false. So it means saying non-blocking to create a non-blocking socket. Then what you do is you do socket.connect, and then you have to catch this exception, which is silly because the default condition is actually an exception, which is silly, but just bear with me for this code. So in our case here, what happens is what do we do now? So what we do is that we have a request, which is this string, an HTTP string. We're going to encode it in ASCII format. Then what we're going to do is we're going to do a busy wait loop. We're just going to while true, socket.send. We're going to send this encoded string. So remember, the first thing we do is we try to get the we do a get request to this URL, right? So what a get request to this URL does, I didn't explain last time, which is get me the homepage of xkcd.com. So this is literally having your web browser go like this. It's basically like that. Is whenever you load xkcd.com, it's a get request, and then the response is the contents of this web page in HTML format. So anyways, here, when we, let's look at both these guys. So we set up a socket, we set it non-blocking, we try to connect, and then hopefully it works. And then what happens, we go down here, and while true, we try to send the get string to the server. And so why is this in a while true block? And it's because this is the tricky part to understand about async first, right? So how fast does this code run? This code runs pretty fast. Line 1 runs pretty fast because, so again, these two blocks are together, right? They're one piece of code. We're going to start running here. This is pretty fast. I'm just creating an object in memory. This is really fast. I'm just setting some flag. Now this call, when the socket was blocking, when it was the default socket from the above example, this took a while to run, right? This took, half a second, whatever. But because the socket is non-blocking, this will run pretty much instantaneously. What this non-blocking socket means is that whenever you make a call, a method call in the socket, it will return to the program immediately, and then it will just do its thing. So that means that when I run this socket will connect and it will run the next line of code. Well, I mean, it runs the exception handler and passes. It will jump to the next line of code and then this line. So it goes fast, 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 fast here. So notice how nothing was blocked or slowed down. Your program will just go lightning fast, boop, 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 all the way through here. Now, the problem here is that now we have a while true. The problem here is that when we try to do a socket.send, what happens? Most likely, unless your connection happens super fast, which we won't, because your computer is really fast, it goes it zips down here. When the socket tries to send, it will give an error because the socket isn't connected yet. There's nothing to actually send to. So it'll give an error, and then the OS will catch the the program will catch the error. It'll pass, and then it'll go back to while true. And then it will try again and try again, try again. This is called a busy waiting loop. So this just goes back and forth really fast, maybe a bazillion times, and just says, send, send, send. Just try to send this darn message. Pretty much every time it errors, and until the socket actually is ready a second later or whatever, this send will succeed. And then once it succeeds, it will break out of the loop as soon as it succeeds, and it will just print send. So this is the first pass of writing asynchronous code. You have to do this. And the reason why you have to do this while true loop that's annoying is because the program just flies right past all these lines without waiting to see if you're connected. So as you might suspect, this seems pretty inefficient because it's tying up the CPU, right? You're just spinning your wheels. You're tying up your CPU. A lot of other bad things can happen when you read. You can find it when you read the article. But essentially, you're tying up the CPU and just basically saying you keep on trying to hit send without it being ready yet, and then when finally it's ready, you break out of the loop. So we really want to do better than that. And obviously there's a way to do that. And it's called something like a select system call. They call it different things like poll, KQ, epoll. But basically what this concept of a select system call does is it just basically says, I want to create a socket and I want to listen to see when the socket is ready for me to say send something. And as soon as it's ready, I can receive an event and I can run some code. So I don't have to do a while true loop waiting because it's super inefficient. So Python 3.4 has this thing called the default selector, which is pretty cool, which is basically abstracts over all the different select implementations on the operating system. So we can just import this as is, and we just create a default selector object. So how does this code work now? So in this version of the code, we are not writing any while true loops anymore. So we're not bashing our CPU. So we create a selector, we create a socket again, set it non-blocking. Again, we're going to do connect, but then this code just goes whoop, it just zips right past because it doesn't wait. We're going to define a function, which is super fast, right? Defining a function is also super fast. So the code just basically zips from the front to the back without really pausing. While the code is now down here, the connect call is being run, say, in the background, right? The OS is taking care of it. Now we're going to have our selector register some file descriptor. So socket has a file node, which is a file descriptor number. So just some ID. And we're going to register on an event called event write. And it's called event write because we want to know when the socket is writable. So when is the socket ready to be written to and have stuff done to it. And when it is ready, we're going to pass in a third parameter, which is the name of the connected function. So this is not a function call, this is just a function name. So this is often called a callback function because this function is called whenever some event happens. So again, all this code runs almost instantaneously, and now the selector has registered this socket's ID with a special type of event called event write, which is when the socket is writable or ready to be written to. And so the way to read this code is when this socket is ready to be written to, only at that time call the connected function. So remember, the connected function is defined here. It's not called yet. So when we're going to run this, this whole thing runs really fast. And then now, a second later, when your connect call is done, a second later, 2 seconds later, however slow your internet is, now the connected function runs. So this function runs maybe a second or 2 seconds or however many seconds after you start the connection, whenever the connection is ready, depending on how slow your internet is. So now we've achieved what we wanted to do with the while true loop, except we didn't need to keep thrashing our CPU by saying, are you ready to send? 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 We can very elegantly just say, hey, tell me when you're ready to send, and I'm just going to call this connected function. So the first thing the connected function does is actually unregister the socket from the selector, and they do this so that you don't get a duplicate event. So the connected only runs once, right? So once you've once you're connected, I don't care about the event write event anymore. I want to clear it so I don't double execute connected, and I just print connected. But really, what you can do within connected is now that you know that the socket is ready to be written to, you can do stuff like socket.send or just send a get request to it and then get data back. So this code looks a bit more convoluted, but it lets you avoid this while loop problem. So now what we can do now is we need to figure out a way to have the selector actually call this connected function. So so when I said that this is registered, this actually doesn't call it all automatically. So, in the end, what happens is this gets called, but you actually need to um, define your own loop manually. So this code goes with, this code goes together with this code. Okay, so let's try to put them on the same screen. Almost fits. Okay, so again, this defines everything. And then what you really have to do is, where's the loop call at the bottom? Well, you have to call the loop function. I'm surprised they don't call it, but you have to actually call it. So this defines a loop function that actually, weirdly enough, has a while true inside. So we'll get back to that in a minute. So while true, it says events equals selector.select. Remember the selectors are our default selector up here. It calls the select function or method. Now it will iterate through events, which grabs a bunch of tuples of keys and masks. The thing we care about inside each event is called an event key. And then the data is the thing we actually pass into it. So this data, this connected function name is event key.data. And then we're going to pass it into assign to a local variable called callback. And then we're just going to call the callback with a set of parentheses. So this calls the callback function. So when we run this, this will actually call into connected. So the way this loop works is that imagine you had a bunch of different things waiting on different sockets, right? So imagine this is one socket right here, right? One socket. And we register it with our selector. Now, what if we had 100 sockets because we wanted to download 100 web pages at once? If we had 100 sockets, we could register all 100 sockets, say, with the selector. And when we do that, then some sockets are going to be connected and ready earlier than others. And we need a way to kind of pull out what's ready and do stuff with it. So in this while true loop, although it is a while true loop, it doesn't bash your CPU, because the difference here is that this while true loop will just literally keep running really, really fast, because this socket.send is a non-blocking operation. So it'll go boop, 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 and just keep on going. The difference between this while true loop and this one, even though they look similar, is that this while true loop, this will actually block, right? So selector.select is a blocking call. So this is kind of confusing because we talk about using non-blocking sockets, but selector.select is a blocking call, which means that this will pause your execution of your program until some event happens, right? So some socket is ready to be written to or something. Then it'll assign it to events, and you do the callback, and then you're going to go back here. So, and then you're going to wait again until another socket or set of sockets has stuff ready, and then you're going to call the callback, and then you're going to go back here and you're going to wait. So this while true loop may, the iterations of this while true loop may take a few seconds each because we're pausing on this select right here. So in this way, if you have, say, 100 sockets open to 100 different websites, depending on how fast the websites get back to you, this select will fire whenever some website or some socket is ready to be written to. And when it's ready to be written to, we're going to grab the callback function from the events list. It could be more than one, that's why it's plural. And then we're just going to call the callback function. And then we're going to go back to waiting in this loop. So this is actually a really important concept because we have a single threaded application that's sort of like, if you squint hard enough, this is kind of like the multi-threaded example we originally put, right? Because imagine instead of spawning 100 threads, I create 100 different sockets in one thread. I register all 100 of them with my selector, and then I let them, and I send a connect message to all 100 of them, and then I just let this loop run. So what this loop does is that whenever somebody is ready, I don't know which of the 100 is ready, I'm going to run their callback function, and then I'm going to wait, and whenever someone else is ready, I'm going to run their callback function. And the hope here is that this will execute kind of efficiently because many of them might be ready around the same time, right? So the idea is that we're going to wait, if I have 100 of them, we might not have to wait forever for one of these selects to fire, because chances are some web page will be ready to be downloaded at any given moment. So that's the basics of asynchronous style programming.